So good evening everyone. I am Shivani Dhok and I welcome you all for the week 3 tutorial of this course. If you have any queries at any point of time, you can just quickly unmute yourself and ask the queries. And like every week, this week's tutorial will also be divided in two parts. First, a quick recap of week 3 content followed by questions related to week 3. So let's start with the recap of week 3 content. So this week 3 started with some properties of convolution. So basically we showed three properties of convolution. The first one is associative property. So what it says is, if I have an input, let's say xn, then I convolve with another system. After that, I again pass the output of this system to another system, then this will be my output. This will give me exactly the same result if I do this, that is pass the same input through a system whose impulse response is something like this.
Hello.
So this is an equivalent system response which for a cascade system. So this thing here is known as the associative property. Another thing that we looked at is the commutative property. It says that H1 convolved with H2 is exactly equal to H2 convolved with H1. And the next property that we did was distributive property. So if I pass an input through one system, then add the output such that I have with output of another system with impulse response H2, then this is equivalent to passing the same input through a system with impulse response H1n plus H2n. So this kind of thing is known as parallel. Yes, sir.
Madam, associative property of convolution is common or it is restricted at any
Yes, sir. Please
constant?
ask your query.
You are telling the convolution property
Just
of
a moment. Yeah, please ask.
Madam, you are telling the associative property.
Properties of convolution, yeah. This is not a transform, this is property of convolution. Convolution as a function. This has nothing to do with transform and other things. This is properties of convolution as a means convolution as a function, mathematical function, nothing else. Hello?
Hello?
Yeah.
I heard that associative property of
Sir,
convolution.
1 minute. Let me rejoin the meeting. It's very difficult. Just let me
Okay.
rejoin the meeting.
Okay.
Hello, ma'am.
Hello? One second.
Are you hearing me, madam?
Yeah. Yeah.
Mursal.
Please.
Madam, associative, I heard the convolution property, associativity of convolution, I heard that it is conditional. Is it true or not?
Conditional.
I'll put in mail, madam.
Okay, I didn't
I'll
understand.
put in a mail. I'm referring to put in a mail.
Okay, I didn't understand
This
what.
I'll put up a discussion form or like that.
Yeah, please.
I heard that, but I'll make it the details in the mail, madam.
Okay. I didn't understand what do you mean by convolution as a.
I would have referred, but I'll do it in madam.
Yeah, please.
Got me, madam?
Yeah, please do it in the discussion forum. I'll answer there.
Hello.
Hello?
Hello.
Yeah.
Yeah, I'll put the details in mail or in discussion form, madam.
Uh,
I'll put it in a letter, madam.
yeah, fine.
Fine.
Thank you.
Yeah.
Yeah.
Okay.
So
Yeah.
yeah.
Yeah. So. Yeah. Am I audible? My system is behaving very badly today. Some settings are wrong. I'm using different systems. So if you can't hear me, just put in text box or raise the hand. Put in chat box or raise the hand. I'll immediately act on it. Yeah, Siley.
Yes, I'm getting you clear.
Yeah. Sorry.
Can you hear me?
Yeah, I can hear you.
I can hear you.
Yeah, I'm saying I'm getting you clear. It's much better now.
Okay. Yeah. Thanks.
And I want you to reduce the screen. I want to read associative the question in front of it. I want to read it. I'm not seeing the ending.
Sorry, I didn't understand what you're saying.
Convolution property.
Yeah.
Oh no. Okay, like that. Thank you.
Yeah.
I'm seeing now.
Yeah.
Tick.
Huh. Okay. So after that, Vivo stability was discussed. This Vivo indicates bounded input, bounded output stability. So what does it say? That if I send a bounded input to a system and it gives us a bounded output, that is known as Vivo stability. And for LTI systems, this Vivo stability reduces to the condition that my impulse response is absolutely summable. After that, for causal systems are those systems where if we have an input, let's say x1n, and it is equal to another input x2n, for all n less than or equal to some particular value, then in that situation, the output corresponding to yn, let's say y1n, is equal to the output corresponding to x2, which is y2n, for all these n values. So what does it indicate is there is no sort of future dependency. Like x1, if I am looking at the output at n equal to 1, then that output won't depend on the input value at n equal to 2, 3 and so on. So such a condition is known as causality. Another thing is memoryless systems. So for a memoryless system, the output just depends on the current value of input. Neither past nor future. So the input-output relationship will be basically some function of only xn, so that yn will be equal to some function of x of n only, neither x of n minus k nor x of n plus k. Next thing that we
Next thing
saw
that
was
we
the
saw was
frequency
the
response
frequency
of
response of
LSI
LSI
systems.
systems.
After that, we
After that,
discuss
we
linear
discuss
space of
linear space of
sequences and
sequences and
interpretation of
interpretation
frequency
of
response
frequency
as dot
response as
products
dot
and
products and
as
as
eigenvalues.
eigenvalues.
This was all
This
the
was all
things
the
that were
things that
discussed.
were
If you have
discussed. If you
queries on
have queries
anything,
on
just let me
anything,
know.
just let me
Otherwise,
know.
I'll go
Otherwise,
ahead
I'll go
with
ahead with
questions.
questions.
Okay.
Okay.
If there are no
If there are
queries,
no
then let's
queries,
start
then
with the
let's
very
start with
first
the very
question.
first question.
So, as I
So
had
as I
mentioned
had
in
mentioned in
all the previous
all the previous
lectures,
lectures,
this lecture
this
also
lecture also
corresponds to some
corresponds to some
questions which were
questions which
there
were there
in the last
in
year's
the last year's
assignment.
assignment.
So let's start
So
with
let's
the
start
first
with the
question.
first question.
So what it
So
says
what it
is,
says is,
match the
match
pairs
the
in the
pairs
table
in the
given
table
below,
given below,
considering the
considering the
statements are for
statements
an
are for
LSI
an
system
LSI
with
system
impulse
with
response
impulse
h of n.
response h of n.
So if we are
So if
having
we
a
are having
memoryless
a
system,
memoryless
what
system,
does it
what
mean?
does it mean?
So one thing you
So one
should
thing you
take care
should
that
take care
this
that
thing,
this
whatever we
thing,
are
whatever we
discussing,
are
is only
discussing, is
for
only
this
for
LSI
this
system
LSI
and
system and
nothing, no other
no other
systems.
systems.
Okay.
Okay.
So in that
in that
situation,
situation,
what
what
does a
does a
memoryless system
memoryless
look like?
system look like?
So as I
So as I
mentioned
mentioned
earlier,
earlier,
for this
for this
memoryless system,
memoryless system,
this
this
output y
output
of n
y of n
should only be
should
a
only be a
function of
function of
x of n.
x of n.
So this y
So
of
this
n
y
could
of n
be,
could
let's
be,
say,
let's say,
some
some
constant
constant
multiplied by
multiplied by
xn,
xn,
or it
or
can
it
be,
can
one
be,
approach is
one
this,
approach is
second
this,
thing can
second
be
thing can be
alpha
alpha
xn
xn
plus, let's say,
plus, let's say,
beta with
beta
some
with some
shift.
shift.
Next thing
Next
can
thing
be
can be
some
some
another
another
nonlinear function
non-linear
of
function
xn,
of xn,
let's say some f
let's say some
tilde
f
of
tilde of
xn, where
xn, where
this is a
this is a
nonlinear function.
non-linear function.
And fourth
And
thing
fourth
could
thing
be
could be
some f
some f tilde
of
of
x of
x of
kn.
kn.
Now what we
Now what
observe
we
is
observe is
these two
these
things are
two
anyway
things are
out of
anyway out of
our look,
our
because
look,
these
because these
two systems are
two systems are
100% not
100%
LTA.
not LTA.
Yes, sir.
Yes, sir.
Is it second, madam? 1 2 seconds. Multiplication.
But
Huh,
now
but now
one is
one
okay.
is
One
okay.
is simply
One is
scalar
simply scalar
multiplication. Now
multiplication.
just
Now
look at
just
this
look at this
second part.
second part.
Can this
Can
system
this
be
system be
additive?
additive?
This is time
This is time
invariant, I
invariant, I
understand. Can this
understand. Can
system
this
be
system be
linear?
linear?
It is shift
It is shift
invariant, but it
invariant, but
can't be
it
linear.
can't be
For
linear.
example,
For example,
let's say
let's
x1
say
equal to
x1
2 for
equal to
all
2
n
for
and
all n
x2
and
equal to
x2
3
equal
for
to
all
3
n.
for all n.
Then x1
Then
plus
x1
x2
plus x2
is 5.
is 5.
So my
y
for this
for
particular
this
thing will
particular
be
thing will be
alpha 5
alpha 5
plus beta.
plus beta.
But my
But my
y1
y1
is
is
alpha 2
alpha
plus
2 plus
beta, and
beta, and
y2 is
y2 is
alpha 3
alpha
plus
3
beta,
plus beta,
and
and
y1
y1
plus
plus
y2
y2
will be
will be
5
5
alpha
alpha
plus 2
plus
beta.
2 beta.
So these
So
two
these
things
two
are not
things are
same.
not same.
Therefore, this
Therefore,
thing
this
is
thing
also a
is also a
non-linear
non-linear
system. So
system.
this
So
thing
this
particular
thing
second
particular
thing is
second thing is
non-linear.
non-linear.
So therefore,
So
this
therefore, this
first option, memoryless
memoryless
system,
system
should
should
correspond to
correspond
only
to
scalar
only scalar
multiplication to the
multiplication
input
to the input
and nothing
and
else.
nothing else.
No
No
addition of a
addition of a
constant,
constant,
nothing else.
nothing else.
Only this
Only
kind
this
of
kind of
system will be
system
a
will be a
memoryless
memoryless
system when
system
we are
when we are
constrained to
constrained to
look
look
at
at
LSI
LSI
systems.
systems.
Is it
Is
clear?
it clear?
Yeah.
Yeah.
Please ask.
Yeah, actually, I got a doubt.
Yeah.
Does absolutely integrable or absolutely simple means that this system should be linear?
No, no.
No, no.
System should be
System should be
LSI,
LSI.
linear and
Linear
shift
and shift
invariant,
invariant.
but
Okay, so
but stable.
Stable.
okay, then how do we check for absolutely integral? Just like you did, so we can randomly take any two values.
In that
In that
situation, you should
situation, you
know
should
what
know
your
what
h
your
of n
h of
is
n is
for all values
for
of
all
n.
values of
So
n.
if you
So
know
if
what
you
h of
know
n
what h
is,
of n
then you
is,
can
then
look
you
at
can look at
absolutely
absolutely
summability or
summability or
absolutely
absolutely
integrability. We
integrability.
have one
We have
question
one
for
question
that
for that
in coming
in
slides.
coming
So yeah,
slides.
this will
So
be
yeah,
much
this
more
will be
clear
much more
that time.
clear that time.
Okay, ma'am. Okay, ma'am.
Yeah.
Yeah.
Is memoryless
Is
thing
memoryless
clear?
thing clear?
Okay.
Okay.
So after
So
memoryless,
after
the
memoryless,
second
the
thing
second
that we need to
thing that
match
we
is
need to
this
match
causal
is this
system.
causal system.
So as I
So as
mentioned,
I
there shouldn't
mentioned,
be a
there
future
shouldn't be a future
dependency.
dependency.
And for
And for
such kind of
such kind
systems,
of
when we are
systems,
just
when we
looking
are
at
just looking at
LSI,
LSI,
then this
then
impulse
this impulse
response
response
should
be
should be zero for
zero
all
for
the
all the
non
non
negative value.
negative
Sorry,
value. Sorry,
all the negative
all the
values of
negative
n.
values of n.
This we had
This we
derived
had
in the
derived in
normal
the
class
normal
lecture.
class lecture.
Then the next
Then
thing,
the next
as
thing,
just
as just
she
she
mentioned, when we are
mentioned, when
having
we
a
are having a
stable
pivot
system
stable
and it
system
is an
and it
LSI
is an
system,
LSI system,
the
the
impulse
impulse
response
should
should
be
be absolutely
absolutely
summable.
summable.
And if it is
And
an
if it is an
invertible
invertible
system,
system,
then
then
what does an
what does
invertible
an
system
invertible
mean?
system mean?
Let me add a
Let me add a
page.
page.
So what does an
So what does an
invertible system
invertible
mean?
system mean?
So it means
So
that
it means
if I
that
give
if I give
xn as an
as an input,
then I
then
have
I have
output
output yn,
which is
which
equal
is
to
equal to
xn
xn
convolved with
convolved
hn.
with hn.
Now, if
Now,
this
if
system
this
is
system is
invertible,
if invertible,
then there
then there
exists another
exists
system,
another
let's say
system, let's
h
say
tilde
h
n,
tilde n,
such that
such that
if I
if
give
I give
yn as an
yn as
input,
an input,
then I
then
get
I
output
get
as
output
xn.
as xn.
And this thing
And this
here,
thing
this
here,
xn
this
will
xn
be related
will be related
to
to
h tilde
h tilde
n
n
convolved
convolved
with
with yn,
and
and
this thing
this
is
thing
related.
is
So for
related.
example,
So
if
for
this is
example, if this is
convolution, then I am doing something
doing
with this
something with this
output to get
output
back
to
my
get back
input.
my
So this is
input.
like
So this is like
reversing the
reversing
process.
the
So
process.
such kind of
Such
thing
kind
is
of
known
thing
as
is known as
deconvolution.
deconvolution.
So that's why
So
if my
that's why
system
if
is
my system is
invertible,
invertible,
I can
I
have
can have
a
a
deconvolution
deconvolution
happening.
happening.
Any queries?
Any queries?
Any questions?
Any questions?
Okay.
Okay.
If there are no
If there are no
questions,
questions,
then
then
let's move on to the next
next
question today.
question today.
So this is the
So
question
this is the
2 that I
question
have
2 that I
planned to
have
cover.
planned to cover.
So it says
So it
that
says that
which of the
which of the
systems
systems
described by the
described
following
by the following
equations are
equations
causal.
are causal.
So we need to
So
check
we need
for
to check
causality.
for causality.
So is the first
is the
system
first
causal?
system causal?
Yes, ma'am.
Why?
Why?
Because current
Current
output
output
is
is depend on current input
and
and
past
past
values
values
of
of
input.
input.
Right, correct.
Right, correct.
So what is
So
happening
what is
here
happening
is,
here
let's
is,
say I look, let's say
I'm
I'm looking at
looking
the
at
output
the
at n
output
equal
at
to
n
3.
equal to 3.
So if I'm
So
looking
if
at
I'm
n equal
looking
to
at n
3,
equal to 3,
then
then
this
this
thing
thing
is x of
is
3
x
and
of
this is
3
x
and
of
this is
0.
x of 0.
So at
So
any
at
particular
any
time
particular
instant,
time
at any instant, my current output will never depend on the future values of input.
of input.
And that's
And
why
that's
this
why
is a
this is
causal
a
system.
causal system.
What about
What about
fourth
the
one?
fourth one?
This one.
This one.
Is it causal?
Is it causal?
With the same
With the
logic?
same logic?
Yes, ma'am, this will also be a causal system.
Yes, because the
Yes,
current
because the
output
current
is
output
depending
is
only on
depending
the
only on
current
the
input.
current input.
Not even
Not
past.
even
It is
past.
depending
It is
on
depending
the
on
current
the
input.
current input.
So this is
So this
basically
is basically causal.
Also,
Also,
additionally, this is
additionally, this is
memoryless.
memoryless.
Okay.
Okay.
What about second?
What about second?
It's
It's
non-causal.
non-causal.
Yeah, and why is
Yeah,
it
and
so?
why is it so?
For
For
current
current
input,
input, it demands the future.
current
Current
output, it
output, it
demands the
demands the
future
future
input.
input.
Okay.
Okay.
So let's
So
check
let's
it.
check it.
So if I
So
am
if I
looking
am
at
looking at
y equal
y
to,
equal to
let's say
let's say
5,
5,
then
then
this is equal
this
to
is equal
x
to
of
x of
minus 5
minus
plus
5
3
plus 3
equal to
equal to
x of
x of
minus 2.
minus 2.
So for this
So for this
particular
particular
input, it is depending on
depending
past
on
value.
past value.
But
But
now if I look
if
at
I look
y
at
of minus 5,
minus 5,
then this will
then
be
this will
equal
be
to
equal
x
to
of
x of
5 plus
5
3,
plus 3,
which is equal
which
to
is equal to
x of
x
8.
of 8.
So here we
So
are
here
having
we are having
future
future
dependency.
dependency.
So this
So
future
this future
dependency
dependency
shouldn't be
shouldn't
there
be there
for all
for
values of
all
n.
values of n.
It might
It
happen
might
that
happen that
there is no future dependency for some particular value of n,
value of n,
but
but
there might be future dependency for other values of n. So this thing should be satisfied for all values of n, and this is not happening for this particular system. That's why
this is
non-causal.
non-causal.
Similarly, if we look
if
at
we
the
look at the third
thing,
here,
if we observe
if we observe carefully,
for current instant, the output is depending on the current instant as well as the input value which will be available after two time instants. So what I mean by that, if I look at y of 1, then this will be equal to x of 1 plus 1 times x of 3. So here again we are having future dependency. So therefore this system is also non-causal. Any queries? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Anyone has any other questions related to this causality? Okay. So let's move on to the third question. Yes.
Ma'am, there is a question. Is anti-causal and non-causal is one and same?
No. So what happens in non-causal? I'll just draw two impulse responses, and then it will be clear to you. So what happens is for an LSI system, I'm saying this thing. Okay. So this comment I'm making is for LSI system only. So for LSI system, if I have an impulse response which is something like this, this is 0. And before n equal to 0, everything is 0. Then such kind of system is causal. This is h of n.
Then
Then if I have a system which is something like this, so you observe that for some values, for some values of n, h of n less than 0, h of n is not equal to 0. So this is non-causal. And for anti-causal, what we have is this is n. So for all values of n greater than 0, it will be 0 like this, and here it will be non-zero. So such things are anti-causal. So one note that you can make is every anti-causal system is non-causal, but the opposite is not true. Is it clear now?
Yes,
Yes,
ma'am.
ma'am. Yes, sure.
Yeah. Okay. Any other questions? Okay. So let's start with the third question. So it says that we know that the complex exponential e power j omega n are eigenfunctions of LSI system, provided that they are applied through the time range, that is minus infinity less than n less than infinity. What would be the output of an LSI system with impulse response Hn and frequency response h of omega for the input x of n e power j un, where un is the unit step function. Okay, so this is the question. So what we are having is we have a system h of n, which is this is impulse response of the system. Then we are given the frequency response, which is h of omega. This is frequency response, and by definition this quantity is summation n running from minus infinity to infinity h of n into e power j omega n. Sorry, minus j omega n. Okay, so this is the frequency response, and these two things are given to us. Now another thing that we are given to us is if my input xn is equal to e power j omega n u of n. So what does this mean? This thing is basically equal to 1 for n greater than or equal to 0, and it is 0 otherwise. Just a minute. Yeah. Okay. So this is equal to 0 for n less than 0. Okay. So this we know. So now we need to find the output corresponding to that input, and we know that it is an LTI or rather LSI system. So this output y of n is simply convolution of xn with h of n Or this we can
Or this
also
we can
write
also
as
write as
convolution of h of
convolution
n
of h of n
with
with
x of n.
x of n.
Okay.
Okay.
So this I can now write as summation.
Summation
By definition
by
of
definition
convolution,
of
this I can
convolution,
write
this I
as
can write as
summation k
k
running from
running
minus
from
infinity
minus
to
infinity to
infinity
infinity
h of k
h of k
into
into x of
n
n
minus
minus
k.
k.
Now what is my
Now
x
what
of
is
n?
my x
My
of n?
x of
My
n
x
is
of
e
n
power
is
j
e
omega
power j
n
omega
un.
n un.
So I can simply
So I can simply
substitute
substitute
that. So
that.
this is
So
equal to
this is equal to
summation
summation
k running
k
from
running
minus
from
infinity
minus
to
infinity to
infinity
infinity
h of k
h of k
into
into e power j omega
n minus
n
k
minus k
into u
into
of
u of
n
n
minus.
minus k.
So now what
So
we
now
know
what
about
we
this
know
u of
about
n
this u
is
of n
this u of n
this
is
u
equal
of
to
n
1
is
for
equal to
n
1
greater
for
than or
n
equal
greater
to
than or
0,
equal to
or
0,
rather
or
for
rather
those
for
values
those
values of n,
values
for
of n,
this
for this
argument is greater
argument
than or
is
equal
greater
to
than or
0.
equal to 0.
That is
That is
this quantity
this quantity
should be greater than
should
or
be
equal
greater than or
to
equal
0.
to
So this
0.
n
So this
minus
n
k
minus k
should be greater
should
than
be
or equal
greater
to
than or
0,
equal to
or
0,
this
or
k
this k
should be less than
should
or
be
equal
less than or
to
equal to
n.
n.
Only in that
Only in that
set of
set
values
of values
this quantity
this
will be
quantity
equal
will
to
be equal to
non-zero,
non-zero,
otherwise it will
otherwise
be
it will be
0. So
0.
this I
So
can
this
write
I can
as
write as
summation
summation
k running
k
from
running
minus
from
infinity
minus
to
infinity to
infinity
infinity
h of k,
h of k,
or rather
or
k
rather
running from
k
minus
running from
infinity
minus
to
infinity to
n
n
h of k.
h of k.
Hello, your screen is not updated.
Is it not
Is it
updated
not
for
updated
everyone,
for
or
everyone,
it's
or
just for
it's
you?
just for you?
Because
Because
I am
I am
reflecting it on
reflecting
two
it on
screens,
two
so
screens,
on
so
one screen
on
it
one
is
screen it is
updated.
updated.
Yes, ma'am, it's updated for us.
Okay, sir,
Okay.
please check
Sir,
with
please
your
check
internet
with your
connection
internet
once.
connection once.
My screen is clear. I can see it clear.
Yeah, okay,
Yeah,
thank you.
okay, thank you.
Yeah.
Yeah.
So in
So
this
in this
particular
particular
thing, this e
thing,
power
this e
j
power
omega
j omega
is
is
j omega n
j
is
omega n is
independent, so I can
independent,
just
so
take
I
it
can just take it
outside
outside
into e power
into e
minus
power
j
minus j
omega
omega
n.
n.
Okay,
Okay.
so this we
So
are
this we are
having.
having.
Now what we
Now
need to
what
do
we need
is
to
we
do
need
is
to
we need to
write this
write this
output in terms
output
of
in terms of
frequency
frequency
response. So
response. So
somehow we want to
somehow we
bring
want
in
to
this
bring in this
particular
particular
h of omega
h of
term,
omega term,
and what we
and
observe
what we
is this h
observe
of
is this
omega
h of
is varying
omega
from
is varying from
running from minus
running from
infinity to
minus infinity to
infinity.
infinity.
However, this
However,
summation is
this
running from
summation is
minus
running from
infinity to
minus
n.
infinity to n.
So this
So
particular
this particular
summation
summation
I can write
I
as
can write
follows:
as
e power
follows:
j
e power
omega n
j
as
omega
it
n
is.
as it is.
Then I can write
Then
it
I can
as
write it as
summation
summation
k running from
k running
minus
from
infinity
minus
to
infinity to
infinity
infinity
h of k
h of k
into e
into
power
e
minus
power
j
minus
omega.
j omega.
Sorry,
Sorry, this will be
this won't be
this
n, this
will
will
be
be
n. This
k.
will be k.
Yes, sir.
Yes, sir.
Get only.
Okay, yeah.
Okay, yeah.
J omega
J
k,
omega k,
and from this
and from
entire
this
thing we'll
entire
need to
thing we'll need to
subtract
subtract
k running
k
from
running from
n plus
n
1 to
plus 1 to
infinity
infinity
h of
h
k
of k
into e
into
power
e
minus
power
j
minus
omega
j omega
k.
k.
Now if you
Now if
observe
you
carefully,
observe
this
carefully, this
particular
particular
thing here, this is nothing but
nothing
h
but
of
h of
omega.
omega.
So this we
So
can
this
now
we
write
can now
as
write as
e power
e
j
power
omega
j
n
omega n
inside the bracket
inside the
h of
bracket h
omega
of omega
minus
minus
summation
summation
k running
k
from
running
n
from
plus
n
1 to
plus 1 to
infinity
infinity
h of
h
k
of k
into e
into
power
e
minus
power
j
minus
omega
j omega
k.
k.
Is it okay?
Is it okay?
Any
Any
questions?
questions?
Yes, sir.
Yes, sir.
Is it final answer, madam?
Yes.
Yes.
We can't
We
simplify
can't
it further.
simplify it further.
Okay. Thank you.
Yeah.
Yeah.
So what is
So
happening
what is
here is
happening here is
this additional
this
term
additional term
which is coming
which
up.
is coming up.
This is coming
This is
due
coming
to
due to
multiplication with u
multiplication
of n.
with u of n.
And if I
And
consider
if I
only this
consider
term,
only this term,
this will be
this
there
will
if
be
I'm
there if I'm having
input only as e
input
power
only as
j
e power
omega
j
n.
omega n.
Any other questions?
Any other questions?
Can you back the second page once?
Yeah, sure.
Yeah, sure.
Yeah.
Yeah.
Just let me know
Just
once you're
let me know
done.
once you are done.
No, lot of audio disturbance was there, and video was not able to get it.
I think
I
video
think
issue
video
is
issue
not
is
there
not
with
there
everyone,
with
right?
everyone, right?
No, now it's okay.
Okay.
Earlier.
Okay.
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 Yeah.
Yeah.
Anyway, this
Fine.
recording
This
will be
recording
there
will
on
be there
on YouTube.
on
Yeah,
YouTube.
go ahead.
Yeah.
Go ahead.
Yeah.
Okay, so let's
Okay,
start
so
with
let's
the
start
fourth
with the
question.
fourth question.
Just bring your last question back.
Yeah.
The
Yeah.
answer, the last one. Yeah, right there.
Yeah.
I want to
Yeah.
complete.
Yes, sir. Please
Yes, sir.
ask.
Please ask.
Madam.
Yes.
Yes.
Can be a polynomial be analytic function?
Polynomial B?
Polynomial B?
Analytic function?
No, it won't
No,
have
it won't have non-zero
difference.
difference.
What do we say?
What do we say?
But for the assignment, it was taken as the correct option, madam. Last assignment.
Just put in the
Just put in
discussion
the
forum.
discussion forum.
I kept also. I understood only sine and exponentials are analytic.
Yes.
Yes.
Given third degree polynomial, that also is accepted as correct one. I don't know why it happened.
Just put it in
Just
the
put it
discussion
in the
forum
discussion
once.
forum once.
Yeah, I kept, madam.
Yeah. I'll
Yeah,
also
I'll
comment
also
on it. I'll
comment on
request
it. I'll request
the
the
TAs which handle
TAs
the
which handle
assignments
the
to do it.
assignments to do it.
Yeah.
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 Okay. If there
Okay. If there are no other
just
questions, just
let's start with
let's
the fourth
start with the
question.
fourth
So
question.
this is a
So this is a
simpler one.
simpler one.
So
So
what it
what
says
it
is
says is
what is the
what is the
equivalent
equivalent
impulse
impulse
response if
response
two
if two
LSI
LSI
systems
systems
are
are
connected, one in
connected, one in
cascade and two in
cascade and two
parallel?
in parallel?
Then
Then
let's do this
let's do
first
this
one
first one
first.
first.
So
So
let's say
let's say
the two
the
systems
two
have
systems
impulse
have
response
impulse
h1
response
of n
h1 of
and
n
h2
and
of n.
h2 of n.
So if I'm
So if
having
I'm
it in
having it in
cascade,
cascade,
what does
what does
cascade mean?
cascade
So
mean?
cascade
So
simply
cascade
means
simply
that I have
means
one
that I have
system
one
h1
system
of n,
h1 of n.
then output
Then
of that
output of
system
that
goes
system
to
goes to
h2 of n,
h2 of n,
like this.
like this.
So we have
So we
seen
have
that
seen
for
that for
cascade, this
cascade, this
equivalent impulse
equivalent
response
impulse
h of
response
n
h of n
is simply
is simply
convolution of these
convolution
two.
of these two.
And if it is in
if it is in parallel,
so what does
so
parallel
what does
mean?
parallel mean?
That same
That same input
goes
goes through
two different
two different
systems,
systems,
and it
and
is
it is added
to get the
to get
output.
the output.
And for this
particular case,
the impulse
the impulse
response
response
h of n
h of n
is simply
is simply addition of
the two
the two
individual
individual
impulse
impulse
responses.
responses.
Is it clear?
Is it clear?
This was
This was
discussed
discussed
with detailed proof in the class. Still, I kept this as a question or simple question.
Simple question. Just one.
Now let us go on for the second part. What it says is if h of omega is the inner product of h of n and e of j omega n. So what it's saying is this h of omega is inner product of the sequences h of n and e power j omega n. And if h of omega converges, then this quantity h of omega is the component of this quantity h of n in the direction of which sequence. So when we are having inner product between two sequences, so what we are doing is we are finding the component of one sequence onto the another sequence, just like how we project. So this h of omega is component of h of n in the direction of the sequence e power j omega n. Is it okay?
Ma'am, what's the difference between product and inner product?
Product is between two scalar quantities. Like let's say 2 into 3. And this inner product is basically multiplication of two vectors and adding. So if you're having a vector, let's say 1, 2, 3, and another vector 3, 4, 5. One thing that you can do is element by element multiplication. That is 1 into 3, then 2 into 4, then 3 into 5. That is just element by element multiplication. What inner product does is it does element by element multiplication and add that multiplication also. So by definition, if I am having two sequences, let's say x and h, these are two sequences. Let's say complex sequences. Then by definition, this is n running from minus infinity to infinity. X of n into h of n conjugate. So this part you can say as a product, but yeah, inner product is a property for it is a term that we generally use in vector spaces and different spaces. So I don't know how to compare these two things. I think we shouldn't also.
Okay, ma'am. Okay.
Yeah, these two are totally different things.
Okay, ma'am.
Yeah. Any other questions? So what you can do is take up this as a definition of inner product between two sequences. It is defined in this fashion. It's a definition for this particular thing. Any other questions? Yes, sir.
Madam, the answer is completed?
Yeah, the first one was solved now. Second part is completed. What is asked is the if h of omega converges, h of omega is component of h of n in which direction? In the direction of which sequence? So it is component of h of n in the direction of this sequence. Yeah.
Okay.
Yeah.
Madam, just one more question.
Yes.
Suppose I want to judge whether it is LTI or not. Is the network can contain at least one time component or not?
Sorry.
Suppose I am having a network. I want to judge it is LCCDE or LTI like that. And that network should have at least either inductive component or capacitive component, no? Not necessary.
Not necessary. Only resistive network can also be.
But resistive network is not at all time dependent, no?
No, it's not at all time dependent.
Then how can we that will take the time invariant?
Yeah, your output Y of t, you're applying some voltage, let's say VT.
This question I am asking, this is one of the options in one option is inductor capacitor, not resistors like that. But solely resistors will solely resistor network. Can we consider that as LTI or some other thing?
We can consider it as an LTS.
I see.
Yeah, if you go for simple Ohm's law, V equal to IR, and if my I is what do we say, input, and a voltage is output that I'm looking at, then my V of t directly depends on my I of t, that is current instant. So yeah, it is linear and time invariant.
Okay.
Yeah.
Thank you.
Okay.
So let's start with the fifth question. So suppose an input signal xn is equal to a power n un, and this magnitude of a. Just a minute. Yeah. So suppose an input xn is equal to a power n un, where this a is having its magnitude less than 1, is applied to an LTI system whose impulse response is h of n. So we need to find the output y of n. So again, by definition, this y of n, since it is an LTI system, this is simply convolution of xn with h of n. So this we can write as summation k running from minus infinity to infinity x of k into h of n minus k. So this we can write as summation k running from minus infinity to infinity. Let us substitute the value of xk and h of n minus k. So this xk will be a power k into u of k, and this h of n minus k will be simply u of n minus k. Now let us look at the case where these two things, this particular thing will be non-zero. That is, this particular product will be non-zero. And when will it be non-zero? When both of these u of k and u of n minus k will be non-zero with respect to the variable k and not n. Okay. Yeah. So how does this u of k look? So this u of k.
Then can you put it back? Last second.
How will this u of k look? So this u of k will be 1 for all values of n greater than 0, and it will be 0 otherwise. So this is my u of k. And how will this u of n minus k look? So for that what we'll do is we'll first look at u of minus k. So this u of minus k will look something like this. And it will be 0 otherwise. Okay. Then what we need to look at is u of k minus n, like this. This we need to look at, which is simply u of n minus k. Okay. So now if if my
If
n
my
is
n
negative,
is negative,
that is if my
that
n
is
is
if my n
negative,
is
then I'll have
negative,
to
then I'll
shift
have
this
to shift this
like this.
like this.
And
And
if in that case,
in
if I
that case, if
multiply
I
these two
multiply these two
signals,
signals,
then it will be
then it will be
0.
0.
However, if
However,
I
if
have
I
my
have
n
my
greater
n
than 0,
greater than 0,
then in that
then in that
situation,
situation,
this will be
this will
shifted
be
by
shifted
n
by n
like this,
like
and
this,
then there will
and
be
then
some
there will be
overlap.
some overlap.
Therefore, for
for
n greater
n
than
greater
0,
than 0,
that is when we are
that is when
shifting
we are
this
shifting
signal
this signal
rightwards, it will be
it
something
will be
like
something
this.
like this.
For some
For some
instant, let's say k,
and 0
and 0 otherwise, and it will be
again
1 here.
here.
Now what we need
Now
to do
what
is
we
we
need
need
to
to
do is we need to
multiply these two
multiply
signals. These two,
this
one
one
and this one.
and this one.
So if we do
So if we
element by
do
element
element by element
multiplication here, that
multiplication
is
here,
this
that is
multiplied by
this
this,
multiplied by this,
this multiplied
this
by
multiplied
this,
by this,
this multiplied by
this
this, like
multiplied by
that.
this, like that.
So this will be non-zero only for the values of k from 0
from
to
0
n.
to n.
Is it clear?
Is it clear?
Yes.
Yeah.
Yeah.
So therefore,
So therefore,
this summation here, the limits of this summation, now I can replace from 0 to n, and I can go do away with this particular multiplication. When will it be true? Only when my n is greater than 0, or rather n is greater than or equal to 0. And when my n is less than 0, then in that situation, I am shifting it just a moment. Yeah. So I'll have to shift this particular signal like this to the left, and in that situation there won't be any overlap, so that product will be 0, and therefore this entire convolution will also be 0. So this y of n, let me add a page, and I'll copy the same equation again. This y of n is equal to summation k running from minus infinity to infinity, a power k u of k into u of n minus k. Now this thing is equal to 0 if my n is less than 0, and this thing is equal to 1 if n is greater than 0 and k belongs to 0 to n and 0 otherwise. So now what I can do, one minute. Yeah, I can write this as summation k running from minus infinity, or k running from 0 to n, a power k and this should be multiplied by u of n. Is it clear? Okay. So now this is simply a geometric progression with first term as 1. So this I can write as 1 minus a power. The number of terms are from 0 to n. So there are n plus 1 terms. N plus 1 upon 1 minus a into u of n. Is it okay?
Okay.
Any questions here?
Ma'am, we are already given that rho of A is less than 1. So we can also replace it by 1 minus A.
What? I didn't understand.
When in the question we are given that the value of A is less than 1.
Magnitude of A is
Magnitude
less
of A
than
is
1.
less than 1.
A can be
Okay,
in
ma'am.
general
Okay, ma'am.
complex.
Okay, ma'am.
Okay,
Yeah.
ma'am.
Yeah.
Ma'am,
Yeah.
Yeah.
can you show the last part right now? ठीक है, it's okay.
Yeah.
Yeah.
Any other
Any other
questions?
questions?
Okay, madam.
Okay.
Okay.
If there are no
If there
questions,
are no
then
questions, then
let's
let's
move
move
on
on
with
with
sixth question
sixth
for today.
question for today.
So,
So
what it says
what it
is,
says
consider an
consider
LTI
an
system
LTI
with
system
impulse
with impulse
response
response
h of n,
h of n,
which itself
which
is a
itself is
cascade
a
of two
cascade of
LTI
two LTI
systems
systems
with impulse
with impulse
responses
responses
h1 of n,
h1 of n,
this one, and
this one,
h2
and
of n,
h2 of n,
and we need to
and we need to
compute h of
compute
n.
h of n.
Okay.
Okay. Yeah.
So since it is
So
in
since it is in
cascade,
cascade,
this h of
this
n
h of n
is equal
is
to
equal to
h1 of n
h1 of n
convolved with h2 of
h2 of n.
Okay.
Okay.
So we need to
So
find
we
out
need to
this
find out this
convolution. So
convolution.
before going on with this part, let us simply finish off answering the second part as well. So it says
So it
that
says
repeat the
that
same
repeat
if the
the same if
systems
the
are
systems are
connected in
connected
parallel.
in parallel.
So if they are
So if
connected
they are
in
connected
parallel,
in parallel,
this h
this
of n
h of n
will be simply
will be
equal
simply
to
equal
h1 of
to
n
h1 of n
plus h2
plus
of n,
h2 of n,
which will be
which will be equal to
1 by
1 by
5 to the
5
power
to the
n
power n
plus 2 by
plus 2 by
5 to the
5
power
to the
n
power n
into u of
into
n,
u of n,
which I can also
which I can
write
also
as
write as
1 plus 2 to the
2
power
to the
n
power n
upon 5 to the
upon
power
5 to the
n
power n
multiplied by
multiplied by
u of n.
u of n.
So this is the
So this
answer
is the
for
answer for
second part.
second part.
Now let us
Now
solve
let us
the
solve the
first part.
first part.
So what it
So
says
what it
is
says is
this h of
this
n
h of n
is combination of two cascades, so that's why we'll have convolution of the individual impulse responses. And what knowledge we have? We have this h1 of n is equal to 2 by 5 to the power n into u of n, and h2 of n is equal to 1 by 5 to the power n into u of n. Okay.
Okay.
Yeah. So we are having this. So now we
So
can
now
just
we can
use definition of this convolution. So we have summation k running from minus infinity to infinity, h1 of k into h2 of n minus k. So this thing here we can write as summation k running from minus infinity to infinity, 2 by 5 to the power k into u of k into 1 by 5 to the power n minus k into u of n
n minus k.
Now this 1 by 5 to the power n is a common thing. I can just take it outside. It is independent of k. So this I can write as 1 by 5 to the power
n
into
summation
k running
k
from
minus infinity to infinity.
Then I can combine this and this part. So this I can write as 2 by 5 into 5 by 1 to the power k into u of k into u of n minus k. So what I'm having now is this is equal to 1 by 5 to the power n summation k running from minus infinity to infinity 2 to the power k into u of k into u of n minus k. Now if you observe carefully, this thing is similar, is exactly the same thing that we saw in the previous question. That is here. It's the same thing that we saw here. So what we observed is for n equal to 0, for k running from 0 to n, please unmute yourself, sir.
For k is equal to 0 to n, okay?
Yeah.
Then we can write it as summation of k is equal to 0 to n.
Yes.
So this thing is same what we had discussed. So again the limits of the summation which we are having can be changed. So the limits of the summation can be changed from 0 to n. I request the participants to please mute when you don't have any questions and freely unmute when you want to ask a question. Yeah. So this I can replace as k equal to 0 to n 2 to the power k, and this thing is valid only for n greater than or equal to 0. So I can simply write it as u of n. Okay. And this summation is simply a geometric progression again with n plus 1 terms. But now this 2 is greater than 1. So instead of 1 minus something, this will be that something minus 1. So this I can write as 1 by 5 to the power n into 2 to the power n plus 1 minus 1 upon 2 minus 1 into u of n. So therefore, now my impulse response of this cascade system is h of n equal to 1 by 5 to the power n into 2 to the power n plus 1 minus 1 u of n. Any questions?
Please show the slide from first slide to last.
Don't worry, these notes are available in the drive. I'll upload them in the drive. You will get it.
Okay.
Yeah. Don't worry. Any other questions?
Madam.
Yes.
Madam.
Yes, sir.
Suppose we have given two vectors. To calculate upper bound, is it inner product is the solution?
Sir, we'll see. I have a question regarding that. We'll see it.
Okay.
Yeah. For this particular question, are there any doubts? This upper bound, inner product, and all those things I'll cover. I'll cover.
Okay, thank you.
Yeah. Okay. So let me go ahead with the next question. Yeah. So what does it say? It says that determine the range of values of P and Q for which the LTI system with impulse response h of n is stable. So it is an LTI system. So let me be a bit more specific. Range of values of magnitude of Q for which LTI system with impulse response h of n is stable. Yeah. So it is given that it is an LTI system and it is a stable system. So for stable and LTI system, my impulse response should be absolutely summable. That is summation n running from minus infinity to infinity, magnitude of h of n should be less than infinity. That is, it should be finite. That is what it means by when we are saying it is absolutely summable. So now let us compute this particular thing. So what we need to do is we need to find summation n running from minus infinity to infinity, magnitude of h of n. So how does my h of n look? So for all the values of n which are less than 0, that is for n equal to minus infinity to minus 1. So for n equal to minus infinity to minus 1, h of n is p power n. So I can write it as magnitude of p to the power n plus for n greater than or equal to 0, h of n is q power n. So this is summation n running from 0 to infinity q to the power n, or rather magnitude of q to the power n. Now observe this thing is an infinite geometric progression with first term as 1 and common ratio as magnitude of q. And this thing will converge if this common ratio is less than 1. So I now have a handle on this second term, that this particular term will converge when my magnitude of q is less than 1. But for this entire summation to converge, this thing should converge and this thing should also converge. So now let us look at this term here. Okay. So let me add a page. So what we are having is this term. We have this thing with us, and we saw that this is less than infinity if magnitude of q is less than 1. And now let us look at this term only. So this term, what I'll do is let k equal to minus n. So if that is the case, then this limits will change from 1 to infinity. And this will be magnitude of p to the power minus k. Or this I can also write as summation k running from 1 to infinity 1 by magnitude of p to the power k. Okay. Now again, this is an IGP or infinite geometric progression with first term as 1 by magnitude of p and common ratio as 1 by magnitude of p. And for this particular summation, this infinite geometric progression to converge 1 upon magnitude of p should be less than 1, or equivalently magnitude of p should be greater than 1. So what we are having is we have this summation here, and what did we show? This particular quantity is less than infinity if magnitude of q is less than 1, and
and
this quantity,
this summation
is less than
is
infinity
less than infinity
if magnitude,
magnitude of P
is greater than
than 1.
So what does it
So
say?
what does it say?
It says that
this
quantity, that is the absolute summation of my impulse response, is less than
infinity if
magnitude of
P
is greater than
1 and
magnitude of Q is less than 1. Is it clear? Any questions?
Any questions?
Any questions
in this part?
No, ma'am.
Okay.
Okay, madam.
Yeah. If there are no questions, then let's move on with the next part. Yeah. So till now, majorly we were looking at the questions which are related to properties of system. So the remaining three questions that I have planned to cover today are related to basis or rather orthogonal things, then inner products, and finding some sort of upper bound or lower bound, that kind of things we will look at. So these are related to spaces like vector space or space of sequences. So let's start with the first question. So what it says is which of the following is an orthonormal basis for R2? So what does it mean? R2, this thing is space of two-dimensional real vectors or two-dimensional real values. So basically it will have two-dimensional vectors, and since it is two-dimensional, it will have two vectors in its basis. So what is a basis? Basis are two vectors which are linearly independent, and we can write entire vector space in term using these two vectors. For example, if I need to represent a two-dimensional vector, let's say 2 and 3, I can write it as 2 into 1 0 plus 3 into 0 1. So these two vectors are sufficient enough to write any given vector in the R2 space, that is real space. So these two vectors are linearly independent. Also, basically when we are saying linearly independent, then they are orthogonal. Also, they'll have a magnitude of 1 or norm of 1. So these are known as orthonormal. So two orthogonal vectors. What do we mean by orthogonal? If inner product, we write it properly. So if x and y are two vectors, then if inner product is equal to 0, then it means that x and y are orthogonal. But if x comma y is equal to 0 and x comma x is equal to y comma y is equal to 1, then we say that this thing is norm square. This is also same thing. So its norm is 1, and that is, it is having one unit norm, and those are orthogonal. So then such kind of vectors are known as orthonormal. Okay. So what we need to check is which of the following these values, which of these four given sets, which of them are orthonormal. basis
basis
R.
for R.
Okay.
Okay.
So let's do
So
it
let's do
one
it
by one.
one by one.
So let us look at the first one. So is it orthogonal? So for that, let's say this is X and this is Y. So this X, comma Y is simply equal to, we need to do element by element the multiplication and then summation. So this thing will be minus 0.707 into 0.707 plus 0.707 multiplied by, so this quantity will get multiplied by this into minus 0.707. So this thing is basically minus 2 times 0.707 square. So this thing here is not equal to 0. So these are not even orthogonal. So these are not orthogonal. So no need to check for orthonormal thing only. These are not orthogonal only. So therefore this thing is not orthonormal. So the first given set does not form an orthonormal basis. This one. Is it clear?
Yes.
Yeah. So now let us look at this second one. So again here the first vector we'll consider as x and second as y. So now let us look at x, comma y. So this is my x, this is y. So what is x, comma y? So that will be 2 into 0 plus 0 into 6. So this thing is 0, which means that these vectors are at least orthogonal. But we need to check if these are orthonormal. So for checking orthonormality, we need to look at the norm of individual vector. So we need to look at this quantity. Or let's just look at this quantity. So this is x, comma x. So what does x, comma x mean? So what I need to do is 2, 0. So individually this will be 2 into 2, 4 plus 0 into 0, 0. So this is 4. Okay. Or this I can also write as. I can also take this thing as take element by element square. So this I can write as 0 square. So for this particular thing 0 square plus 6 square, which is 0 plus 6, that is 36. So now this is not equal to 1 and this is also not equal to 1, which means that these are not orthonormal. So this thing is also no. Now let us look at the third one. Now this we can just understand by observation only. But still let us do it. So we'll just let's look at orthogonality. So this will be 3 into 6, that is 18 plus 5 into 10. That is 50. So this is 68, which is again not equal to 0. So these are not orthogonal. So since they are not orthogonal, no need to check for norms. So this thing is again not an orthonormal basis. Now let us look
Now
at
let
the
us look
fourth
at
one.
the fourth one.
Let us look at
Let
this.
us look at this.
So
Again this is
x,
this is x,
y.
this is y.
So let us look
So
at
let us look
x,
at x, y.
So this thing
So
here
this thing here
is
is
0.6
into
minus
minus
0.8
plus
plus
0.8
0.8
into
into 0.6.
0.6.
So this is
So
equal
this
to
is
0.
equal to 0.
So at least
So at least there
we know that they
we
are
know that they are
orthogonal.
orthogonal.
Now let us
Now
look
let
at
us look at
this quantity.
this quantity.
So this will
So
be
this will be
0.6
square
plus
plus
0.8 square. So this is
So this is
0.36
0.36
plus
plus
0.64, which is equal to 1.
equal to 1.
Then we have
This
this
quantity,
quantity, which will be again minus 0.8 square
plus
plus 0.6
0.6
square, which is
which is
0.64 plus 0.36, which is again 1. So therefore, these are having unit norm, and that's why this is orthonormal. Now since these are orthonormal bases, so yeah, this thing forms an orthonormal basis. Any questions?
Any questions?
Okay, madam, proceed.
Ma'am, it is mandatory to have both, that is x and y orthonormal, or either of these two is orthonormal, can be okay.
This set should be orthonormal. A single vector can't be orthonormal. Set of bases.
Okay.
Yeah. Orthonormality we check for at least two things. So if your question is for being that set orthonormal, is every vector should have, does every vector need to have a unit norm? So yes, every vector should have a unit norm. But along with having unit norm, it should also be orthogonal. So orthogonal plus having unit norm corresponds to orthonormal set of vectors. Okay. Yeah. Any other questions? Okay. If there are no questions, then let us go ahead with the ninth question that I have planned. So what it says is, suppose V1 bar, V2 bar and V3 bar are n-dimensional vectors, where V1 and V3 are orthogonal to each other. So what information do we have? So we have three vectors V1, V2, V3 which are n-dimensional, and it is given that V1 and V3 are orthogonal. So what does it mean? The inner product of V1 and V3 is 0 since they are orthogonal. Okay. Next thing that is given to us is, suppose this quantity, that is norm of V1 bar is root 2. What does this norm look like? So this is this quantity. So under root of V1 bar, or rather under root of inner product of V1 bar and V1 bar is equal to root 2, or this I can write as simply V1 bar, V1 bar is equal to 2. and it is given that inner product between V1 and V2 is 1. So this quantity is equal to 1. So this we know. So what we need to do now is we need to find a lambda that satisfies this equation. So what relation do we have? So we have this V3 bar is equal to V1 bar plus lambda times V2 bar. So this we have. And we need to find a lambda that satisfies this equation. And we need to use only whatever information is given to us. Okay. So what we know is so inner product of V3 with V1. Inner product of V3 with V1 is 0. Then inner product of V1 with itself is 2. And inner product of V2 with V1 is 1. So this is the information that we are having. So we know the values of inner product of each of these with V1. We know its values. So let us try to exploit that and find the relation. So what we'll do is let us do this. V1 V3. So this is equal to 0. It is given to us. Now using the relation that we are having. So using this relation that we are having, this thing I can also write as V1 comma V1 plus lambda times V2 bar like this. Now these inner products are linear in nature. So this is equal to. So this thing is equal to inner product of V1 comma V1 plus P1 comma lambda times P2. Okay. So this is equal to V1 comma V1 bar. Now again this lambda thing here. This inner product is also homogeneous, so I can take it outside. So this is V1 bar comma V2 like this. So now what do we know? We know this V1 this quantity here. This quantity here is equal to 2. So I can substitute it here. So this is equal to 2 plus lambda times this inner product is equal to this quantity here. So this is simply 1. So this is lambda plus 2. And what is this? This is basically inner product between V1 bar and V3 bar, which is equal to 0. So this quantity here is equal to 0. So therefore this lambda is equal to minus 2. Any questions? Okay, if there are no questions, then let's go ahead with the 10th question that I have planned to take today. Okay. So this is also a question from last year's assignment, and probably this kind of thing might help you to find some upper bounds or lower bounds, whatever is asked in your assignments. So for this case, what we are given is so we are introduced to one thing which is known as Cauchy-Schwarz inequality. So it says that the magnitude of this thing
this
here.
thing here.
Inner product
Inner product
is less
is
than or
less
equal
than or
to
equal to
norm of vectors. Multiplication of norm of vectors. So this Cauchy-Schwarz inequality says that this quantity is less than or equal to and equal. Yes.
This question are from assignment number 1, right?
Sorry.
Assignment number 1. These are the questions, right?
These are the questions from last year's assignment number 3.
Okay.
Yeah, those assignments are not available to you. Yeah, last year's assignments for same course for last year's.
Okay.
Yeah. So with equality, if this U bar is some linear combination, some scalar multiple of V. So this is the Cauchy-Schwarz inequality. So you can use this to find out any upper bound or lower bound, whatever is asked. It might be useful based on whatever situation you are having. So this I can also say that this. Okay. Yeah. So we are having this thing here, and what it says is find the lower bound on this quantity where A, B, C, D, and E are positive real numbers. So let us try to bring on this thing here. Like use this particular thing in order to find this lower bound for this quantity. So for that, what we'll do is first of all consider this A plus C plus D. And what do we know about them? These are positive real numbers, which means that if I take square root of A, it is a well-defined thing. So this thing I can write as under root of A square plus under root of B square plus under root of C square plus under root of B square plus under root of E square. Okay. So now this thing is equal to finding an inner product of these two vectors. Or rather, inner product of this vector with itself. Right. So this thing is simply norm of this vector but squared. So when we are having a norm, we have a square root outside, which is not there. So square root of this quantity is norm of this vector. So here we are having a norm square. Now similarly, let us consider this quantity here. So what we have? So now let us consider by A plus 1 by B plus 1 by C plus 1 by D plus 1 by E. So similar to previous case, this also I can write as 1 by root A square plus 1 by root B square plus 1 by root C square plus 1 by root D square plus 1 by root E square. Okay. And similar to what we have seen here, this thing is norm of the vector 1 by root A, 1 by root B, 1 by root C, 1 by root D, 1 by root E squared.
Is this
part
is it clear?
Okay.
Yes.
Yeah. Okay. So now if this is clear, so what exactly do we need to find out? We need to find out the lower bound on this particular quantity. So now let us focus on that quantity. So now consider this thing, that is A plus B plus C plus D plus E multiplied by 1 by A plus 1 by B plus 1 by C plus 1 by D plus 1 by E. So this thing we have found out as this first part. This thing is equal to this part here. Okay. So this thing I can write as norm of root A, root B, root C, root D, root E squared. And this quantity here is exactly equal to this quantity. So this I can write as 1 by root A, 1 by root B, 1 by root C, 1 by root D, 1 by root E square. Okay. Now we have this thing here. Let us look at the Cauchy-Schwarz inequality that we are having. So this is our Cauchy-Schwarz inequality. Right. So let me just copy it here. So this we are having. So now what we'll do is let us square it on both the sides. Since it is real, this magnitude is okay. It's less than or equal to norm of u square into norm of v square. So I can just write it other way round. So we have greater than or equal to inner product of these two vectors square. Now let us compare this particular thing, this thing here, and this thing here. So what we observe is this particular thing is equivalent to norm of u square. Similarly, this particular thing here is equivalent to norm of v square. Okay. So these two are equivalent things. So what do we have is this thing which is A plus B plus C plus D plus E multiplied by 1 by A plus 1 by B plus 1 by C plus 1 by D plus 1 by E, which we had found out as norm of root A, root B, root C, root D, root E square multiplied by norm of the vector 1 by root A into 1 by root B into 1 by root C into 1 by root D into 1 by root E square. Yeah, so this we know. Now if we apply Cauchy-Schwarz inequality to this, so this thing is greater than or equal to inner product of root A, root B, root C, root D, root E, and the vector 1 by root A, 1 by root B, 1 by root C, 1 by root D, 1 by root E squared. So this thing whatever we did right now is coming from Cauchy-Schwarz
inequality.
Okay. So now let us find out this inner product. So this thing now will be equal to root A multiplied by 1 by
root A
plus
root B
multiplied by
1 by root B
plus
root C
into 1 by
root C
plus
root T
into 1 by
root T
plus
root E
into 1 by
root E
and
whole squared.
So this
thing is one.
all of these things
just
get cancelled to give 1
each.
So this is
So this is simply equal to 1 plus 1 plus 1 plus 1 plus 1 whole square,
which is equal to 5 square,
which is equal to 25.
So what did we
find out? So we found out that
this quantity
A plus B plus C plus D plus E
multiplied
by
by
1 by A
plus
plus 1 by B
plus 1 by
plus
C
1 by C
plus 1 by
plus
D
1 by D
plus 1 by
plus 1 by E
is greater than
or equal to
25. So this thing
is
is
at least equal to
25. And
And
it has to be greater than or equal to. So there is a lower bound on this particular multiplication. That is, this particular thing can't be below 25. It is bounded
below
by this particular value. So this particular
thing
is lower bound, which we wanted to
find out.
Any questions? Any questions
at this part?
No. Any questions in any part of today's tutorial? This was the last question that I had planned to cover today.
No questions, madam.
Okay. If you have no questions, then you are free to leave the meeting. Thank you for attending today's session.
Thank you also, ma'am.
Yeah.
Ma'am, you have talked about norm 1, na?
Huh?
How to find out norm 2 or greater?
Sorry?
How to calculate norm 2 or greater than 2?
It is a property of that vector. So for example,
let me add a page.
Like how to find
means.
Okay. So if I have this vector 1, 2, or for that matter, let's say 1, 1.
Yes, ma'am.
Let's say this is x. Then norm of x will be equal to under root of 1 square plus 1 square. Okay, so this will be 2. Now if I have a 3-dimensional vector 1, 1, 1, let's say. Let's say this is y. Then this norm of y will be again this thing. 1 square plus 1 square plus 1 square. So you need to take element by element, like square, add them and take a square root. Okay, so this will be root 3. So in general, if x is equal
x is equal to
x1,
x1,
x2,
x2,
and so on
and so
till
on
xn,
till xn,
n-dimensional vector. If this is,
then
then
norm of x
will be
summation
n equal k equal to
k
1
equal
to
to
n,
1 to n,
magnitude of x1
x1
square, and then take square. So if it is a
So if it
complex
is a
quantity,
complex quantity,
you need to take its absolute value and then square.
square.
For example,
For
if
example,
this
if
same
this
thing,
same
if it
thing, if
was
it was
1,
1,
then j,
then j
and 1,
and 1,
then you will have to
then you will
take
have to take
magnitude of j,
magnitude
which
of
is
j,
1,
which is 1,
and you will get
and you
same
will get
norm.
same norm.
Okay?
Okay?
Okay.
Yeah.
But this is norm 1, na?
No.
No.
Norm 1
Norm
means
1 means
Norm 1, norm 2, likewise.
do you mean by L1 norm and
L1
L2
norm and
norm,
L2
those kind
norm,
of
those
things?
kind of things?
Sometimes there is a question that is Euclidean norm 2, Euclidean norm 3.
Okay, so this is 2
this
norm.
is 2 norm.
Okay.
So if you
This
want
is norm 2.
so if you want
So
to
if you want to
find this thing,
find this thing, na,
let's say P
let's say
norm,
P norm,
then this will
then
be
this will be
summation k running from 1 to n,
1 to n,
magnitude of
magnitude of
x1,
x1,
xk,
this should be k,
xk to
xk to the power p,
P.
to the power 1 by p, and this p should be greater than or equal to 1.
Yes, ma'am. Thank you.
Okay?
Got it. Yes.
Any other
Any other questions?
So when it is mentioned Euclidean norm, it is 2 norm.
2 norm.
Okay, ma'am.
Yeah. Yes.
Is it possible to discuss the present assignments, madam? Last week and the previous week we have some doubts. Not just upcoming.
I'll check what you can do. Hopefully a detailed solution will be there uploaded. Okay. So what you do is you go through that solutions and then you post a query on that portal. I'll look at it and discuss that particular question in the next tutorial. Is it okay with you?
Okay.
Yeah.
Madam.
Yes.
Please not yet uploaded.
Okay, just put in the what do we say? The discussion forum. Request them for a detailed solutions. Generally, they post it when they release. They release the solutions as far as I have seen in last 2-3 sessions. 2-3 semesters. Okay. If there are no further questions, thank you all again for joining today's meeting. Hope to see you all in the next session as well. Thank you.
Thank you.